Hi students, welcome back. Today we are going to discuss about modular programming. It is in the fourth module. So what is the meaning of a modular programming? If the program is divided into a number of functional parts, then we used to call it as modular programming. Okay. So in detail we will discuss what is the meaning of a modular programming. I'm just reading the definitions and all for this modular programming. If the main program is divided into subprograms, then we can independently code each submodule later combine into single unit. This type of individual module is termed as a function. So what's the use of a modular programming? Consider we have a program and this program length is more than 500 lines. So it's difficult for the compiler. Difficult in the sense the resource utilization for the compiler is too high if the program length is too high, because compiler have to execute the entire program, then only it will produce the output. Rather than doing like that, we can divide the program into small modules. By dividing these programs or segregating the programs into small modules, we can tell the compiler that you have to execute only this part of the program for this kind of input. So based on that, we can divide the entire big 500 lines of program into small programs, and we are going to combine those programs with the help of a main program. So that small programs are named as functions. So that is the meaning of this statement. Okay. Advantages of modular programming: it's easy to understand the program. That is important thing. Why? Because we are dividing the small programs divided the big program into small programs. So these small programs will explain what exactly it is doing, or the functionality of those particular small program is mentioned there, so that a third person who is going to modify the program can easily understand what's happening there. The second one, debugging and maintenance becomes easy. So it's based on the first advantage. It's easy to understand, so that debugging in the sense if we need any corrections on the program, or if we want to update something, because we are all using mobile phones, a lot of applications are there. In a frequent of time your applications are getting updated. So it's happening based on the requirement of the user. So the developers are updating the applications frequently. Sometimes it may increase the security details, or sometimes it may improve the performance. So whatever it may be, the person who developed the application may not be available in the company. A third person or any other person who is working there, he is going to update that software. So at that time he has to understand the program easily, what's happening there, what is the functionality of this particular program. So if we are doing modular programming, then it will be easy to understand the program. To whom? To the developer or to the software developer. Then debugging and maintenance becomes easy. So we can easily identify the errors, and we can update the software whatever it is required. Okay. Saves programmers and users time. So it's programmers time in the sense he can easily update the program. That is why the programmer can easily save the time. Users time in the sense while running the program, user need not to wait for much time to get the output, because that we will discuss how it is happening with the help of examples. Okay. Reuse the code wherever necessary. That is another important advantage of this modular programming. Once a program is ready and it is divided into small modules, and that modules is named with the help of a function, and if it is available there, we can reuse that particular function. Okay, whenever you need to collect a particular value from the different users. So for that we are writing a particular code. You have to reuse that code, otherwise you have to write each and every time for each and every input. So you can reuse the code wherever it is necessary. That is advantage of modular programming. Very simple example of a modular programming. The splitting of a problem into its related subproblems. Just a diagrammatic representation. So a main program is there. So this main program combines the subprograms. It's named as function 1, function 2, function 3, function 4. This is a syntax or a diagrammatic representation of a modular programming. So this is the example. In this case, arithmetic operations on two numbers. So what are the arithmetic operations? Like a calculator, we are going to write a program for a calculator or a calculator program. So we have to perform, we have four operations there. First one is find the sum, then find the difference, then find multiplication, then division. These are the operations that we have. So if a user want to find any of these output, so at that time what he will do, he will give two numbers, and we will ask the user to perform which operation you need to do, either a sum or a difference or a product or a division, which one you need. So automatically the user choose for example, if he choose the product, then that particular part of the program will execute. For example, this is an example for that. This is a algorithm for that. Take two numbers, that is the first step, and take the product C equal to A star B and print the product. So here the arithmetic operation on two numbers is the main program, and divided the programs into small modules like find the sum, find the difference, find the product, and find the quotient. These are the four sub-programs there, and among these four sub-programs, this program is explained in this particular slide. Collecting the input on A and B and performing the operation like product C equal to A star B and printing the result. So this is a way that we are writing the program in modular programming. Okay. Next, we are discussing about what is a function. A function is a set of statements that takes input, do some specific computations, and produce the output. So this is a process that is happening inside the function. So here, take the input if it is necessary. All these steps are necessary, but some computations if required, that has to be performed. Okay. Take the input, do some specific computation, and produce the output. So our idea is to put some commonly or repeatedly done tasks together and make a function so that instead of writing the same code again and again for different input, we can call the function. Again and again I am telling you that we are reusing the code. No need to write the program again and again for each and every input. If the coding is same, then we will write that code in a separate program, and whenever that code is necessary, we will call that function. Okay, we will call that function, and that function will execute whatever task we mention or whatever task we assigned on that function. It will be executed. Okay, so a function is a set of statements that takes input, do some specific computation, and produce output. Okay, and this is a syntax of function declaration, syntax of function declaration in detail. So this is a return type. Okay. This is a return type. This part return type, then name of the function, then argument type and name. Inside this we will write the function definition of the function. So this is the syntax of this function. So before going to discuss, I will discuss what is the syntax of this function. Why do we need a function? That is important thing. Function helps us in reducing code redundancy. So the word redundancy, again and again saying that we don't need to write the code again and again for getting a result. Rather than writing the same code again and again, we create a function and call it everywhere. That is the main advantage or a need of the functions. Functions make code modular. It becomes really simple to read and use the code if the code is divided into functions. So that is an advantage of doing like this. We can reuse the program so that function or the functionality of that particular program can be reused. Okay, and the third one, abstraction. It's the most important thing is abstraction. Abstraction in the sense hiding is the meaning of abstraction. So here what we are going to hide, why we are going to hide here the functionality of some particular function. For example, if you are writing a program for bank transactions, so we all know that the code deals with money. We are going to deal with money, how much interest that we are calculating, and all that confidential matters are there in the case of a software development of a bank software. So at that time, some details has to be hidden, because in a single project, for example, bank software development, this bank software development is not done only by a single person. It may be done by 2 or 3 or 5 members. Some team may be there to do the operation or to develop a software. So at that time, this core operations like this interest calculation, profit calculation, and all these things should be confidential. So at that time, that part of the function may be developed by 1 or 2 person, and that should not be revealed to the other members. So at that time, he can write the code in a single under a single function, and the other people can use that functionality, or other people can use the code by just calling the function name instead of writing the code and again, or that confidential matter need not be discussed by all other members, because it's confidential. It's a business part of the bank. So bank may not be ready to reveal all those things. So at that time, the team member, 1 or 2 team member may involved in that particular operation, and he don't want to discuss or reveal the confidential or reveal the activities happening in between to all other members. So what he will do is he will write a code under the label function name, and he will distribute that particular function name. The other members can use that function name. The other members may not know what's written on that particular function. So that is the advantage of abstraction. And this is the example for the function declaration. So the name of the function in the last example, we have 4 operations: find the sum, find the difference, okay, then find the product, find the quotient. So now I am going to declare the function for finding the sum. So what is the necessity, or what is the need of declaring a function? That is important. The compiler don't know about the sum. I already told you that 2 types of functions we have. One is a user defined function, and another one is inbuilt function. In the last classes we discussed some string functions, string handling functions like strlen, strcpy, strcmp. These are inbuilt functions. We need not declare those functions there, because the compiler already familiar about the functionality and the proceedings of those inbuilt functions. So all those inbuilt functions are available in the library. All those things are library functions. So compiler are more familiar about all those inbuilt functions. So if we are using a function, if we are declaring as a user in the sense we are programmers, as a user of the compiler is a programmer. If the programmer want to declare if a programmer want to use a function, he has to declare the function, so that the compiler understands that this is the process happening inside this function. So a function declaration tells the compiler about the number of parameters. So these are the parameters. So data types mentioned inside the bracket is considered as a parameters, and the data type of the parameters and return type of the function. So what it returns. Okay, sometimes this function may return a value, otherwise it may not return a value. That we will discuss while writing the program. Okay, so this is a syntax of a function declaration. So this integer part explains about what type of value this function sum is going to return, and what are the parameters this function is expecting to do the calculation. So this is the meaning of function declaration, and this is a simple example of a program using function. In this program we have two parts. The first part is function, user defined function. This is a void main program. So usually every programming language starts its execution from main program. So here, if a number of programs are available above this void main, compiler may not consider those one. The compiler consider from this open brace to this closing brace. That is a very important thing. The execution starts from void main, open brace to corresponding closing brace. So in between we will call the function. So automatically compiler will execute that particular part of the program. Otherwise compiler will not execute this program. That is why we are reusing the code. Okay, compiler may not execute the entire program. Compiler executes the only necessary part of the program. So if it is mentioned in the void main. Okay, here two variables that I declared, a equal to 10, b equal to 20. So our program is to find the biggest value, biggest number. Okay, a and b are the two variables. A contains 10, b contains 20. We want to find the highest value. So here we are going to define a function, and with the help of that function we are finding the highest value. In this case function declaration is not needed. Why? Because the definition, this is said to be the definition of the program. Okay, this is the definition of the program. What is the meaning of that? By defining the function, we are telling to the compiler that this is the exact duty or the function of this particular user defined function. So we are telling directly to the compiler that this is the fact. Okay, otherwise if we are defining the function after the void main, then we have to declare the program. Okay, we will discuss all those in detail. Okay, so in this case we directly define the program above the void main, so no need to declare. If we are using the program like this, then we no need to declare the program. So here int m equal to max of a comma b. So this is a function name. Here we are, because here we have a void main, and from void main open braces to closing braces the execution is happening. Okay, so all the declarations inside the void main is valid only up to its closing brace. Very important thing. If we are declaring something inside the void main, the validity of those variables, for example int a equal to 10, b equal to 20, the life of a and b ends here. Once this closing brace executes, then the validity ends here. Okay, so we have two values a and b, and we are going to find the greatest value with the help of a function. So again the function also needs, so here also need the two values. These two values we need there, then only we can find the greatest value. So we have to pass this value. Okay, we have to pass this value from main function to the sub function. So this is a main function, this is a sub function, user defined function, or we can say it's a sub function. So while passing the value, what we have to do? We have to pass it as a parameter. So here the property of this function is this function is expecting two integer values. So we need to pass those two integer values from here. These two integer values are passed to the max user-defined function, and this user-defined function will return a value. So if the user-defined function is returning a value, then we should have a variable to receive that value. Here int m is a variable, and this m is waiting for a result. Okay, so the property of this max function is this function is expecting a value from the main function. So those values are available in a and b. We are passing that value. So in the void, in the subfunction, the subfunction is receiving those values in the variable x and y, and after that in the subfunction the remaining programs, like if x is greater than y, then it returns x, else it returns y. Okay, so this is a process. So here in this particular step, m equal to, so m is expecting a value from max variable. So max variable, so not max variable, max is a function. So m is expecting a value from the max function. Inside the max function, this 10 and 20 we are passing. So we mentioned a and b because a is contained 10 and b is contained 20. So it is getting passed to the subfunction. So here x equal to 10. Remember, whatever values that you are passing, similar type of variable should be there to receive the value. Otherwise, error may occur. Here we are passing to integer values. So in the receiving side, we have to receive those two values in the corresponding variables, integer variables itself. So int x comma int y. So this a travel to x and b passed to y. So a is passed to x and b is passed to y. Okay. So we got values for x and y. So in the subfunction processing, if 10 greater than 20, if 10 is greater than 20, what's the process? 10 is greater than 20, condition false. So it returns y. Y in the sense it returns 20. Y contains the value 20. So it returns 20. So automatically it come back in the sense this function returns an integer value, and that value is stored in the variable m. And we are printing that value. M is %d m. So m contains 20 and prints the value 20. So this is a working of a function. Okay. So two type of parameters we have. Parameter passing to the function. Two types of parameters we have: actual parameter and formal parameter. The parameters passed to function is called actual parameter. In the above example, a and b are the actual parameters, 10 and 20. So in the above program, 10 and 20 are actual parameters. And the parameters received by function are called formal parameters. In this case, x and y are said to be the formal parameters. So the name of these two parameters are mentioned here. A and b contains a value 10 and 20. So 10 and 20 is getting passed from main function to the subfunction. So this is said to be the actual parameters. And here we are receiving those two values, and those two variables x and y are said to be the formal parameters. In the above program, x and y are formal parameters. Okay. This is just the name, the technical term of parameters that we discuss. The most popular way to pass parameter is pass by value. One more parameter passing method is there, that is pass by reference, but in your syllabus it is mentioned only pass by value. So we are discussing the pass by value right now. We will discuss pass by reference while discussing the pointer. Okay. In this parameter passing method, a value of actual parameters are copied to the function's formal parameter, and the two type of parameters are stored in different memory locations. Here a equal to 10, b equal to 20. So two declarations are there, two initializations are there. So a is equal to 10 and b equal to 20. So initialization is happening here in this program. So this is a main program. So I told you that the validity or the life of a and b starts from this declaration point to the closing brace. This value, the validity of this value is not extended to any of the subprogram. Okay. So we are saying that A equal to 10, B equal to 20. So this life, or we can't access A and B from here, because this is a separate part of the program. We are writing the program in a single window, but this is a separate part of the program, this is a separate part of the program. The values declared in this particular program will be valid or accessible only in this program. The values declared inside this program, here also two declarations are there, x and y. Okay, index and y, declarations are there. So this is a declaration as well as formal parameters. Okay, we are getting the values with the help of a parameters. So the values available in these subfunctions are also, its life also close, or life expires once its corresponding closing braces reaches. So you cannot print x and y value in this void main function. Similarly, you cannot access a and b value here in the subfunction. The only way that we can do is just pass the value as a parameter passing, so that we are passing 10 and 20 with the help of a and b, and this value is received here with the help of x and y, and that processing is happened only with the help of x and y, not with the help of a and b. Okay. So here, passed by value. In this parameter passing method, values of the actual parameters are copied to function's formal parameter, and the two type of parameters are stored in different memory locations. So in our previous program, the values stored in a and b are in different memory location. The values stored in x and y are stored in different memory location. Okay. So this is an example to explain this concept. Okay, this is a main program, this is a sub program. Okay, fun is a function name. We are passing the value x here. Okay, so while passing the value x, listen, the name of the variable is also same, but this x value, this variable, life of this variable x starts from here and ends here. Okay, we can use another x variable in the subfunction. Its life is different, its memory location is different. Okay, it's entirely different variables. These two are entirely different variables, not similar variables. So x equal to 20, we are passing the value x20 to the function fun of x. So that is received here as a formal parameter. So here this x is a formal parameter, here this x is the actual parameter. So here we got x, and in this case I am printing the value of x here. Printf x equal to %d comma x. So the value you are getting here is 30. The value that you are getting here is 30, because we reassign the value of x. While passing the parameter, its value is 20, and in the x variable it is 20, but we reassign the value of x as 30. So while printing the value of x, it prints the value 30, but here it prints the value 20. That is a very simple example to understand the parameter passing. You can execute this program. Okay. In the main function, the value of x is 20, still remains there, 20. Okay. And the value of x in the subfunction is 30. We are passing the value 20 from here and receiving here, and we are reassigning the value of, we are updating the value of x to 30, and we are printing the value. So in this program it prints 30, but in this program it prints only 20. That is the difference. So the values stored in different memory locations. These two are different variables. This is a very important thing. You can run this program so that you can avoid the confusions. Okay. So this is a continuous program due to the scarcity of a space. I mentioned it in like this. So after this program, after this program you can write and you can execute the program. Okay. Thank you for watching the video. If you have any doubt, please contact me.